Hello everyone, welcome back to my channel. Now we are going to start off with course on MCQs on analog electronics. So starting off with question, when p-type substance is connected with positive and n-type is connected with negative terminal, then the p-n junction diode will be in which biased? So it will be in forward bias condition, as the holes and electrons are repelled by battery terminal to overcome the junction and the current conduction will start. So it is B, that is forward bias condition. Next, what is the condition if no external potential energy is applied to PN junction? So it will be in the zero bias form, as when the diode is connected in a zero bias condition, there is no external potential energy which is applied to PN junction. Next, if the temperature increases, then the conductivity of a semiconductor will. So it will increase. Remember, if the temperature will increase, the conductivity will also increase. As the conductivity of semiconductor material increases with increase in temperature, electron hole pair are generated and hence the conductivity will increase. Next, which is the factor on which total number of electron in an atom depends? So it will depend on atomic number, as number of electrons is same as number of protons. So the atomic number is number of proton in nucleus of atom, and the total number of electrons are determined by atomic number. So it is the atomic number which is the factor in which the total number of electrons in an atom depends. What do you mean by outermost orbit of an atom? So it is the valence orbit. In any atom, the outermost orbit is called as valence band. The number of valence electron in the atom is the number of electron present in the outermost orbit or outermost shell of an atom. So it is the valence orbit. Next, what is an energy gap? So energy gap is basically space between two orbital shells. The difference of energy between the bottom of the conduction band and the top of the valence band is the energy gap. So energy gap is the space between these two orbital shells. For insulator and semiconductor it is present, but in metal the conduction band and the valence band will overlap each other. So it is the space between two orbital shells. Next, when were the first solid state devices manufactured? So these were manufactured in 1960. So silicon solid state devices were introduced into the electronic industry in early 1960s. In a RC phase shift oscillator, the minimum number of RC network to be connected in cascade will be, so it will be 3, as the RC phase shift oscillator is used to invert the input for 180-degree phase difference. The single RC network will give 60-degree phase shift, so we need 3 sets of RC network which have to be connected in cascade. The value of R and C can be chosen by this formula. Next, what is the range of energy band gap of semiconductor? So it will range from 1 to 3 volt electron volt. So energy band gap will be of size 1 to 3 electron volt. Example, silicon has 1.1 electron volt. Next, class B amplifier is biased at just cutoff. So class B amplifier works only in the positive cycle of input signal. Class B operation has zero TC bias because zero signal collector current is zero, and hence the transistors are biased at cutoff region. So each will only conduct when the input is greater than the base emitter voltage. So the answer is, at just cutoff, class B amplifier is biased. Next, in an n-type semiconductor material, electrons are. So electrons are majority charge carrier in n-type semiconductor material. Due to electrons, they are in the majority. So it is extrinsic semiconductor which leaves the free electron. As a result, electron has majority. Next, which process is used for adding impurity into a pure semiconductor material? So basically, doping is the process which is known to add impurity into a pure semiconductor to increase its conductivity. Next, what will be the result if the pentavalent impurity is added to pure germanium or silicon? So, n-type semiconductor will be formed, as if relatively or extremely small amount of impurity from pentavalent elements is added into silicon or germanium, then there will be 4 of electrons from covalent bond with silicon or germanium atom. So 1 electron will be free. Due to this, it will be n-type semiconductor. Next, which impurity is added into semiconductor to increase its conductivity? So it will be extrinsic semiconductor. To produce extrinsic semiconductor, impurities are added to pure intrinsic semiconductors. Next, in n-type semiconductor, material holes are. So holes will be minority charge carriers, as there will be more of electron in n-type semiconductor. Which of the following is pentavalent material? So answer is arsenic. Among these is a pentavalent material. How will be extrinsic semiconductor act at the room temperature? So it will act as poor conductor, as in most of the pure semiconductor, the population of thermally excited charge carrier is very small. So it will be poor conductor in room temperature. Next, which of the following is trivalent impurity? So boron is a trivalent impurity. What is the majority carrier of p-type semiconductor? So holes will be the majority carriers. Okay, so if you like my videos, you can also subscribe to my channel, and if you have any doubt, you can always ask me in the comment section below. Thank you.